back, everybody. Our next speaker, she's a React developer and engineering lead at FamilySearch, where she's been building meaningful user experience for over 11 years. That's some serious experience there. Heidi, she holds a degree in web design and development from BYU, Idaho, and she discovered her love for React back in 2019. Since then, she's been passionate about creating intuitive interfaces and collaborating with great teams to build amazing things. Outside of work, she lives in Utah with her husband, and she has 4 awesome kids. And today, she'll be sharing her talk, Hooked with React Hooks. So please join me in welcoming Heidi Sommer.
Thanks. All right. Yes, welcome to my presentation, Hooked on React Hooks. The target audience for this is beginner intermediate at hooks. So if you know how to use useContext in your sleep, this might not be the presentation for you. But if you're with your friends or you're already comfortable, feel free to hang out with us. I'm Heidi Sommer. I live here locally in Utah, and I've been at FamilySearch for 11 years. So where are we talking about hooks? I think when I first started off as a developer, I just assumed that everybody was like masters at everything. Like everybody understood everything for Angular and Express and Webpack. I'm just the only one that doesn't understand Webpack. But as I continued on, I realized that we tend to specialize in different things and we all have different strengths, and that's awesome. That's what makes us so powerful together. But when it comes to hooks, we don't want just the select few to understand all that React has to offer and understand all those hooks. Last year, I was doing phone call interviews, talking to people about React, and I asked a lot of questions about performance and about state management, and I was really surprised how many people had multiple years of React on their resume, but didn't know basic hooks. So I think it's worth talking about it. There are a lot of hooks in React. You can always tell that something is a hook because it starts with the word use. Hooks can be used by other hooks. You can create custom hooks. They can also be used within components. Hooks are functions that you hook into the React state and lifecycle. And I was hoping to be able to go over a whole bunch of them, but I had too much to say, so we're just going to be going over some of them. This is going to be a bit of a fire hose of information, but I have 2 goals. The first goal is to help you understand what hooks are out there. The second is to help you understand when is an appropriate time to use those hooks. That way, when you see a time in your code that you might want to use this hook, you can go out and Google it so that you can go out and add it. So hooks are awesome. I needed to include this image, so this slide has nothing to do with anything, but hooks are awesome. Let's get into it. First off, you have to understand that there's rules when it comes to hooks if you've never used React before. The first is that you can only use hooks at the top level. So what does that even mean? React really cares about the order that you call the hooks because it uses a linked list in order to keep track of your hooks. It doesn't know the name of your list, name of your hook, or anything like that. It just knows that the order that they're called in. So if you conditionally call a hook, then it's going to be confused and you're going to have errors. So never conditionally call a hook, never potentially return before you call a hook. Call the same hooks every single time. The second rule is to only call hooks from React functions. This was highlighted more in the old docs, but I found it hilarious that it was such a big deal that they needed to highlight it in their docs, and so, but that makes sense, right? Only use React hooks inside of React. React is a library for building user interfaces. Every component in React is capable of owning state. That's what makes React so powerful. If you've never used React before and you are trying to do state management inside of React, you might be tempted to do something like this, where you create a variable, when you click on it, you'd expect that number to increment. But this doesn't work because React is just JavaScript, and that's not how JavaScript works. If we take out the pieces, if we take React out, everything becomes much more clear. We wouldn't expect this count function, this count variable to persist in between renders, and so we wouldn't expect this count over on the other side to persist between renders either, because what React is just doing is re-rendering your component over and over and over again whenever the prop changes or the state changes. So that's where useState is going to help us out. useState is going to persist your value in between renders. useState, I use react.useState, but I don't usually do this in my code. Just most of my code has react.use whatever, just because I want just to remind us that this is stuff that's built into React. But it can take an initial value, and then it's going to return an array. The return has the value and the setter, and we can destructure them to name them whatever we want. We like to be able to name them because that's the whole benefit of destructuring them, is because often we have multiple use states within your component. An advanced feature that it has when you're using the setter, you can pass a value into your setter and it will change that state, but you can also pass a function in instead, and that way you have access to the previous state. This is nice for asynchronous situations where your state at the beginning, when you first initialize your call or your asynchronous thing, and that when like 2 seconds later, if your call takes a while, your state might have changed in that 2 seconds, and now we're dealing with a stale state that might have been closed over. So instead, we're going to pass in a function, and that allows us to modify the current state. So altogether, this is what useState looks like. When the user clicks on the button, we're going to call our setter, which causes our value to change, and that causes the call component to re-render. Right, use reducer. The first time I ever used a use reducer was in 2019, and I was brand new to React. Someone was looking at my PR, and they were like, hey, I'm noticing that you have a bunch of use states. That means it's time to switch to a use reducer, right? And I'm like, perfect, great, what's a use reducer? And so I switched it over to a use reducer because I was told to, because it had a bunch of use states, and that might be an indication, but it's not really straightforward like that. Just because you have a bunch of use states doesn't always mean that it's time to switch to a use reducer. Times when you might want to consider switching to a use reducer is when your state is a little more complicated. And basically, it's these two things. First off, when one piece of state depends on another piece of state. And then also, when there are a lot of things that the user can interact with on the page. In both of these circumstances, it's handy to take all of that state management and stick it in one location. This makes it easier to maintain and makes it easier to read. If we don't have all of our logic in one place, like a reducer has to offer, then our state management ends up scattered throughout our app, and that's much harder to maintain. So this is what a use reducer looks like. I have a use state and a use reducer both here because if you understand what a use state is, it's not too big of a step to move to a use reducer. They both take a default value. Most of the time when we're working with our use reducer, we're dealing with an object. I mean, 95% of the time, it doesn't have to be. We have a reducer function that we can pass in. You could do this inline, but most of us don't. And this function is going to calculate your new value. And then when it comes to destructuring, it's an array, and we have a value and a way to initialize your state change. So instead of a setter, it's going to be a dispatch. When you call your dispatch, you're going to describe what types of changes that you want to have happen, like what kind of state change is happening here. So we can pass in increment or set to, and then we can pass any additional values that we find are beneficial. This dispatch is passed to our reducer, and so we have the action, which is whatever's passed to the dispatch, and the old state that are being passed in. And this is what I'm talking about, where all of the state logic, all the deciding power is right here in this function. So whatever is returned from this function, that becomes the new state. And most of the time, we're gonna have a switch statement in here. It's like a common convention. It doesn't have to be a switch statement. That's not built into the API. But when you look at your friend's code or online, that's mostly what you're going to see. So altogether, when the user clicks on these buttons, we're going to use our dispatch function to initialize, to create that change in state, and that's going to be passed to the reducer, which is going to take that action along with the previous state, decide what that new state is, and because our state changed, our component's going to re-render, which is going to reset the view. All right, useContext. useContext is one of those pieces of code that I had to stare at for a long time for it to really, really sink in. And so it was a little intimidating for me. If you feel that way about useContext, I just want you to know you're not alone. And if useContext, if you're like a master useContext and it was super easy for you, then I'm really, really happy for you. The problem that useContext is trying to solve is sharing state within your application. When you have scenarios that are pretty simple, you have data in two places, or a piece of state in two places that need to be displayed. When we can just prop drill that down, we can lift the state up, which is just like a common parent, and then prop drill, meaning we're going to pass that value down and the attributes all the way down to where it's needed. And this works really well. However, what happens when the UI becomes more complex? Now we're prop drilling things really, really, really far. And now the designer wants this to be on the other side of the app, so we need to clean this up, which means we need to clean up all the props being passed. And sometimes we forget to do that, and now the next developer is like, why is this prop even here? But they're too afraid to move it because who knows what it does, and we don't want to be the one to break the app. This problem becomes even harder when we have not just one piece of data being passed down, but tons of data being passed down. So you might go immediately running to useContext, but before you do, you could consider, could this problem be solved by better component composition? These screenshots are from an article called Soul Crushing Components by Kent C. Dodds, and it's a really great article. But you can see here that the APIs of all the elements are more exposed. You can kind of see exactly what's in here, and that also means that we can pass props more directly without having to prop drill them so far. So something to consider. So when to use useContext is when your components are nested very deeply. You don't know when it's going to be used, it's like it's a shared component, or you're creating UI libraries with composable components. Oftentimes we think of useContext on a big part of our code, but sometimes it's handy on small pieces of code where child composable components need to be aware of state of the parents. We've been talking a lot about state management here, but I just want to make sure it's really clear. Context or useContext is a mechanism for teleporting data around in your app and has nothing to do with owning state. That might sound crazy because we so closely associate useContext with state management, but let me show you. So first, we're going to create our context. We can pass in a default value optionally. That would be the value used if we used it outside of our provider. And then we're going to initialize our provider. So we use our named context.provider, and then this is the value that we're going to be teleporting within our app. I want you to notice here that there is no state going on. State has to be something that changes over time, and nothing here is going to change over time. This object is always going to be the same. So there is no state. Basically what it does is it's holding up the value so that all the children below can see it. Kind of like a global variable, but scoped and without the same maintainability nightmares. But useContext typically has state, but that's going to be held with a useState or a user, or if you have something like Redux, whatever. And then you can pass in whatever you want in this value. This can be a function, this can be an array, an object. You can nest things, you can go crazy, just don't go too crazy, because then you're going to run into performance and maintainability issues. Once we've created our provider, and you can wrap this in a function. I chose to wrap this in a function because that's how I typically see it, but you don't have to. I'm going to wrap this then around the children that I want to have access to these values. It's like wrapping the children in a blanket. Everything inside is going to be warm and can access the values. Everything outside can't access those values. And then those children can use useContext, and we pass in the context that we care about, and now we can access that teleported value. Alternatively, sometimes we're working with a bunch of different people who might not be aware that the component that you're creating needs to be used within a certain provider. So we can check to see, hey, because we didn't pass in a default value, we can say, hey, is this default value undefined? Is the context undefined? Then we're going to throw an error and let the developer know that, hey, you need to use this provider, you need to use this hook within this provider. So altogether, we're creating the context, we're specifying the value that we want to teleport, and then we're wrapping it around the children that we care about, and then we're just structuring it the value that we want. Right, useRef. useRef and useState have similarities but have different use cases. They both hold a value, and they're going to persist those values between renders, but instead of an array being returned, we're dealing with an object. And the object is always going to have one prop, and that's current. So whatever you set as the initial value, that's going to become the value of current. useState is immutable, which means that we can't directly modify. If you want to edit something with useState, you have to use the setter. But when we're using a useRef, we can directly modify. So if we want to change the value of our ref, we can just use ref.current equals hello, and then instantly current equals hello. useRef is state that React ignores. That is the big selling point of ref, is that it's going to keep the same reference, but it's not going to cause your component to re-render. React is always going to update unless you tell it not to. And so this is us telling React we don't want to update just because this value changed. And just to be very clear, here we can see we're using useState, and when we click on this button, we can see something changing. We can see the number incrementing on the page. But over here, with useRef, whenever we click on this button, nothing is being incremented. But we can see that we have an onClick and that we're incrementing the value, but nothing is updating. And that's because React ignores ref. So what is that good for? The first is to hold state that has nothing to do with the view. For example, sometimes we want to keep track if our component has ever rendered before. That is state that has nothing to do with the view. The user doesn't need to know if our component has ever rendered before. And so we can put that in a ref. The second is to access a DOM element. Every element in JSX has this prop called ref. So you can create a ref and pass that ref to it. The purpose of this is we can now access this element similar to a document.getElementById. Similar, but a slightly different, same use case though. It goes against React, like what a React is about, to access the DOM directly like this. But it's an escape hatch for a reason, because sometimes for accessibility reasons, we need to put focus on an element, or we need to measure the length, the height of an element, or something like that. Right. useEffect. The purpose of a useEffect is to let you synchronize with systems outside of React. React is supposed to be pure functions, which means something comes in, something comes out, and there's no side effects. Typically in programming, we try to avoid side effects because they're less predictable, they're harder to maintain, the tests are more complicated, but we live in the real world and we're going to need side effects sometimes, such as fetching data, they're using a third-party library, what have you. But we don't want these to run more often than we absolutely have to, because React is rerunning your code over and over again, your function. And so we don't want to be hammering our APIs more than we need to. So we're going to block that. We're going to say, hey, React, watch these values and only call this function right here if these values change. And this will limit the number of times this function is called. If we leave off the dependency array, then our useEffect will run just as often as if we didn't have it in a useEffect. The only difference would be that it would run at a slightly different time, almost like a timeout, but with no number, no time. And because the purpose of useEffect is prevent effects from running more often than they have to, then there is basically no point in having a useEffect without a dependency array. So always have a dependency array. Best practice, whatever variables you have inside of your useEffect, put them in that dependency array. And while that might sound really, really easy right now, you might run into a useEffect that's running more often than you want it to, and your code is getting more complicated, and please stop running more than you need to, and you might look at that dependency array and you're like, maybe I should remove some of these variables. But please do not do that. You have to disable the linter in order to do that in the first place. And typically, if you have to remove items from your dependency array, then you have bigger problems on your hand. And while you might perfectly understand how your code works, the next developer that's in there who doesn't understand why things aren't updating as he expects them to will be confused, and it'll cause issues. So please don't disable the linter. useEffect has an optional cleanup function. This is for like if we want to clean up a socket or we have an event listener that we want to clean up because we don't want to add more event listeners than we absolutely have to. This will run right before your useEffect is about to run. It like runs real quick and then your useEffect runs. The other time it runs is when your component is being unmounted. Because it's expecting a cleanup function, if you use async and await inside of your useEffect, it's going to throw an error because it's not expecting a promise being returned, it's expecting a function. And so if you are using async and await, you'll need to wrap it in a function and then call that function immediately. Alternatively, you could use a dot then, or even more alternatively, you could use React query or something like that. useEffect is one of those components that one of those functions hooks that we get wrong when we first start using it. And you're like, I used it wrong. I know a lot of developers that I look at their code later and I'm like, ooh, you did not understand how to use this at the time. So there's a great article called You Might Not Need an Effect in the React docs, and I highly recommend going and reading it, but I just want to highlight a few things. And the first is that you don't need an effect to transform data for rendering. You can just derive it on the fly. React is super, super fast, so you don't need to do some crazy fanciness. You can just derive it. And even if you were iterating over like millions of values, you still don't need to use a useEffect. You can use a use memo, and we'll talk about that in just a second. The second is that you don't need an effect to handle user events. The most clean and direct way to handle a user event is to create a function and call that function on your onClick. You don't need anything else. Use layout effect. The signature for use layout effect and use effect are identical. So if you understand how to use this function, then you understand how to use layout effect as well. The only difference between the two is when they run. Your useEffect is going to run right after your changes are painted onto the screen, and it's going to run asynchronously. Use layout effect is going to run right before your changes are painted on the screen. Like, React has already decided where your components are going to be laid out, what the spacing is going to look like. It just hasn't displayed it to the user. So this is a chance to like go in really quick and do anything you need to do and then have it run. And it's going to be synchronous, so it's going to block. So when is that handy? It's definitely, you'll know it when you see it. Typically for me, I'll see like a little blip of weirdness, and then I know it's time to switch over to a use layout effect. Right. Use memo and use callback. So to really understand the problem that we're trying to solve with use memo and use callback, we need to go back to our understanding of useEffect. And we also need to go even a little bit further back to the days when we first learned about pass by reference versus pass by value. We have to remember that in JavaScript, arrays, functions, objects, those are all passed by reference, not by value. So React isn't going to check to see if your new function is the exact same value. It's going to check to see if it's a new reference. And because React is running over and over again, if you create an object or a function and then put that in a dependency array, this is going to be a new reference every time, and your useEffect is going to run every time, which is probably not what you're looking for if you're putting it in a useEffect. So what are we going to do? We are going to wrap our function in a use callback, and we're going to specify, hey, this is the value that I care about. If this value changes, then I want you to reclose over this function, and now I have a stable reference that is going to persist between renders. And then with use memo, I'm going to have a function that returns the value that I want to know about. And then this will rerun every time this count changes, the dependency array changes. And now I have stable references in my code that won't cause my useEffect to run more often than it needs to. I have good-ish because in the real world, like this is code, like you would never use this in real life. You would just put this object and this function inside of your useEffect. My advice is that if your useEffect isn't too complicated, just stick as much as you can in there. If it starts to get too long or you need those that function or that object outside of your useEffect, then you have to deal with all this craziness. But just try to stick all of it in your useEffect if possible. The use memo has an additional little help, and that's that it can help us with some performance issues. When we have functions that are really expensive, I'm talking about like functions that take a while to execute, like we're iterating over millions of items of data, or we're processing an image or something like that. Those can cause our UI to become laggy. And so instead of calling this expensive function every single time, we're going to wrap this function in a use memo and only call this function when we absolutely have to. So use memo and its cousin memo, like they always come with a cost. Like you wouldn't just like throw that in just because you want your code to be performant. I feel like as developers, when we hear the word performance, our ears perk up because we want to be good little developers with performant code. But sometimes we might throw use memo in unnecessarily, and so we want to confirm that this is a problem before we just put it in there. Sometimes it's really, really obvious because as we're interacting with the page, we can visibly see the lagginess. But other times, we might suspect there might be a problem because we are all on amazing computers and we think, oh, some poor fellow is on a smartphone that's really old and their performance isn't very good. So what I recommend is to confirm that this is a problem before you actually put your use memo in. And what I'd recommend is using the performance tab. You can see, this is like an example of one that has bad performance. You can just see the CPU all yellow. And if you hover over like the functions in here, you can find out exactly how long it takes. And that's it. Thanks, guys. That's it.